So on quicksort we done a lot of theoretical things, right? Quicksort algorithm, partition algorithm, and analyzing that algorithm. We done many things like that, right? Now let's go to the first problem. How problems will be given in the GATE exam. See, you always remember, it doesn't matter how much I said, it doesn't matter how much you know, right? When you are unable to solve the problem, there is no meaning in that. At the end of the day, if you are comfortable in any topic, right, you should solve the problems, right? You should convert the theoretical things whatever you got till now in terms of problems, right? Are you able to do or not? Are you think like that? Are you able to think like that? With the help of these problems, we will check. At anywhere, if you stuck at anywhere, right? So you can see my explanation, right? Try to get as much as possible. I am starting. See the problem. This problem is there from the quicksort in many GATE papers. This problem there in the previous papers, right? Previous paper GATE examinations, CSE, many times, not one time, two times, I can say almost like 5 or 6 times, right? Please read properly. It is the first problem of quicksort. Read it. I will also read, you also read. Consider the following 3 inputs. Consider the following 3 inputs. What is the first input? 1, 2, 3 and so on, n means ascending order. AO means ascending order. One more input, n, n minus 1, n minus 2 and so on, 1, descending order. One more, n like that, same, means one input is ascending order, one more is descending order, one more is same elements. N I written, if you want 1 also, but one thing, same will be there. Consider the following 3 inputs, those are given. Next one, see the next line. Let C1, C2 and C3 be the number of comparisons required for the inputs 1, 2, 3 respectively to keep in ascending order using quicksort. What is the meaning of C1, C2, C3? Right? To keep the first input in ascending order using quicksort, time complexity is C1. To keep the first input in ascending order using quicksort, number of, not time complexity, comparison, number of comparisons are C1. To keep the second input which is there in the descending order into ascending order using quicksort, number of comparisons C2, number of comparisons are C3, right? This is, I am reading once again. Let C1, C2 and C3 be the number of comparisons required for the inputs 1, 2, 3 respectively to keep in ascending order using quicksort. Means using quicksort you want to keep all those 3 inputs into ascending order. For the first input to do that, right, C1 comparison, second one C2, third one is C3. Next, then what will be the relation between C1, C2, C3 is asking. How to solve this problem? Right, using quicksort we have to, right, see now. It is the first problem. Please, and one more thing I want to say to you. This problem if you are comfortable, quicksort almost you are okay. Right, previous things whatever I explained, please revise them again. Very nice way I explained to you. I felt so good after completion of the quicksort. I felt so good. Easiest way I explained to you. Easiest way. Why it is possible? Why it is happened very easily? The reason is you done lot of work for MedSort. MedSort purpose lot of work you done. Same MedSort only one more variation. MedSort is always 50-50. It is going to be need not be 50 many combinations. That is in 2 different answers came. Right? That is okay. Fine. Quicksort, MedSort you are okay means let's see these problems also. See this problem. 3 inputs, you have to apply quicksort to keep them in the ascending order. Comparison required is C1, C2, C3. What is the relation between them they are asking. How to solve this problem? I will start. And one more thing. See this one. Listen properly. This is a very strong statement I am saying to you. On quicksort any question is came. Indirectly, directly is asking. Right? Not quicksort, partition algorithm. On quicksort any question will come, right? Indirectly, directly is asking partition algorithm only. Partition algorithm is the one which will decide the story. Please be careful. Partition algorithm if you know answer for this also. How? Let me check. Let's start the answer for this problem. I am starting. See, make sure that everyone listen. See, first input. Can you help me? First input is ascending order or not? See this one. First input is ascending order. Take anything ascending order. Let me take 10, 20, 30, 40, 50, 60. Next one. 1, 2, 3, 4, 5, 6. 6 elements. Elements are 10, 20, 30, 40, 50, 60. This is the input. First input is this. Let me explain the first input. Automatically second, third you can do yourself. See this one. So on this input, right? On this input, quicksort algorithm if you apply, how many comparisons we have to take care, right? I am doing now. Quicksort algorithm is nothing but indirectly, directly partition only. Please remember, any problem is given on quicksort, any problem is given on quicksort, right? Instead of thinking how to solve and all, right? Minimum thing what you can do, minimum thing, right? Whatever problem is mentioned, right? Accordingly, take one input of like that. Whatever he mentioned in the problem, accordingly, take one input of whatever way he said, and that apply the partition algorithm. You will get some idea what is going on. Any question on quicksort will come, indirectly is asking partition. So, partition algorithm you have to apply 1 or 2 times on this problem. Please be careful. See this one. On this if you apply quicksort, what will happen? Which is nothing but, on this if you apply partition, what will happen? I will check. See this one. You know partition algorithm very well. So, what is the partition algorithm? See. P and Q, I and J. First element is a pivot element 10, that is fine. So can you help in who will move? J. Partition algorithm, let me do partition algorithm one time. P, Q, I, J. J is there in the second place, that is fine. Let's start now. J is asking. J want always greater. See, J is asking, are you greater? Yes. 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 So J crosses boundary, indication that for loop is over, right? Now whenever for loop is over, see, one time also I not moved. What is the reason? One time also I not moved. The reason is, right? Less than pivot, no one there. That is the reason he didn't move. I always want smaller. No smaller is there. All are greater only. That is the reason I not moved. Anyhow, so for loop is over. Partition algorithm I am doing. Please be careful. Right? For loop is over. This array will be actually divided into 3 parts. Right? Now it may be divided. How many parts? Let's see this one. I think it is a pivot. It is a pivot. Everyone know. Next one. One more thing is it is a pivot. Right? Because of I is not moved. No smaller is there. All are greater. Right? All are greater. See this one. For loop is over. For loop is over. This is the thing what I got. Can you help me know what is the next step? After for loop is over, out of for loop what is this? Swap A of P, A of I. I think swap that itself. Afterwards return I. What is the I value? 1. It will finally return 1. Now some people are asking, sir, after completion of this algorithm, whatever answer we got, can you write now? Let me write. 1 is equal to 10, 20, 30, 40, 50, 60. 1, 2, 3, 4, 5, 6. See this one. 1 is equal to, this is the thing. So can you help me know which element you selected as a pivot? 10. And one more, pivot element went to which place? First place. If you select the 10 as a pivot, right? So first place pivot element went more than pivot element one side, less than pivot element other side. See, less than pivot element other side. See, no one came. No one came. If you want, you can check. Right? So pivot element 10 you took, less than pivot, no one there. Right? All are more than pivot. All are more than pivot. Can you help me one small line now? Is it the best partition or worst partition? Best partition. See, one side gap is came. Is it best partition or worst partition? I think it is the worst partition. Can you help me know why worst partition happened? You are taking a pivot element which is the smallest element. Whenever it is the smallest element, right? I think 10 is the smallest element. If you take the pivot element as the smallest element, after partition algorithm is over, less than him, no one will come. See, left hand side gap is there. Right? Left hand side gap is, and one more thing I want to ask you. On n people, see this one, on n people, partition algorithm if you apply, how many comparisons? Comparison, he is asking comparison. How many? Let's see this one. Partition algorithm on 6 people. If you apply, partition algorithm on 6 people, if you apply, number of comparisons are 6 minus 1. How many? 5 comparison. What is the reason? I think second element onwards comparison started. Comparisons are started from second element. Second element I am asking, are you more than pivot, more than pivot, more than pivot, like that. So comparisons are n minus 1, time complexity is big O of n. Forget about minus 1 plus 1 for the time complexity, because of he is asking comparison, right? Comparisons you have to write 5. If you write exact one, exact comparisons will come. If you write little bit more comparisons will come. Please be careful. If anyone say that 6 elements are there, 6 comparison, if you write, that is also okay, but upper bound is coming. Let's try to write the as actual answer as possible. So 6 elements are there. Second element onwards comparisons will start. I think 5. So partition algorithm on 6 elements, 5 comparison. This is the output. I think same thing will continue further. See this one, partition algorithm I applied one time only, but quicksort means what? Recursion, same story will repeat. I think here also same story. See this, same. What is the answer? I will take this as the pivot, right? I think all are greater than this one. J will cross the boundary. I think this one. Same thing will happen. If you want, you can check. Partition algorithm, let me explain. Let me do once again. What is the answer? 5 elements, 4 comparisons. Right? Same. 20 will go to correct place. Less than 20, no one. All are more than 20. Nothing will happen. See, same thing like this. But one more thing I want to ask, when you know what is going on, right? If you don't know, you go further. But one thing, quicksort means what? You have to apply many times. So I am applying many times. First time is over, this is. I think second time also same. What is the answer? It is the P, it is the Q, it is the I, it is the J. J will ask, are you greater? See this one. Afterwards, PAP himself, same story will happen. I think this indicates, so what is the answer? Next one, right? Roughly, partition of 4, 3 comparisons. 30 will go here roughly, right, like this. For your convenience, I am doing all. But if you know at anywhere what is going on, you can stop. You know that what is going on, you can stop, right? So what is the answer? The 40, 50, 60. Next one, if you apply partition algorithm on 3 people, 2 comparisons, right? 40 will go to correct place, less than 40, no one, 50, 60, right? Next, I think it is the last one. See this one. Partition algorithm on 2 people, if you apply 1 comparison, 50 will go to correct place, less than 50, no one, more than 50, 60, because of 1 element, stop. So these many comparisons. So ascending order, this is the story, always left gap, right? See this one, always left gap. So let me do this also. See, let me do this also. Let me see, I am minimizing, see what happened. See everyone now, see everyone correctly. See everyone correctly now. This is the case, 6 elements. If you apply partition algorithm, 6 elements, if you apply partition algorithm, how many comparison? 5. So, one is the pivot, see this one, 6 elements are there. If you apply partition algorithm, 5 comparison, then what will happen, right? What will happen? Left 0 people, right 5 people. Left 0, 1 is pivot. You may say that sir, total 6, right 5 came, left 0 came. Where is the one more? Pivot already correct. Pivot in between, it's okay. Same way here also, 5 elements are there. What is the answer? 4 comparison. 0 here, 4. Next one, 3, 0 here, 3. 2, 0 here, 2. Next, 1, 0 here, 1. 1 means stop. This kind of tree will come. If you add all of them, 6 elements, what is the answer? Sum of 5 natural numbers. Right? 6 elements, sum of 5 natural numbers. If I want to write the recurrence relation for comparison like this one. See this one? Assume that Tn is comparisons. Assume that Tn comparisons. If Tn is comparisons, you only say, what is the answer? Tn is equal to, number of comparisons for n people is equal to, what is the answer? For n people, n minus 1 comparisons required, right? Remaining is Tn minus 1. Remaining people call recursion. Tn is equal to n minus 1 plus Tn minus 1. N elements, apply partition, n minus 1 comparison. Remaining people will go one side, on them apply recursion again. This is the recurrence relation. See, Tn is equal to comparison, it is the recurrence relation. If you solve this one, what is the answer? This kind of series will come 1 plus 2 plus and so on, n minus 1. Sum of n minus 1 natural number, see this, right? Which will goes to, what is the answer? Big O of n square. To this particular input, number of comparisons are n square. Right? To this kind of input, number of comparisons are n square. Right? See this. Nothing, see, after doing one time, and please make sure, see this one, first time I applied left gap came, again I applied left gap, so I got to know, same thing happening. When you got to know, carefully listen, when you got to know, right, left always, when you got to know the actual relation going on, then only stop. After some people, what they are doing is, they will do partition algorithm one time, they will stop. No. Partition algorithm, when you do one time, right, it may be left gap. When you do second time, same thing may not happen sometime. You please be careful. Can you help me now? When the quicksort algorithm will give best case, always best partition. Partition algorithm, see, when you say quicksort algorithm, inside partition algorithm many times going on. Quicksort calling. Whenever quicksort is going on, quicksort is calling himself many times. What is the meaning? Partition algorithm many times. Whenever partition algorithm many times going on, every time best partition happened, then best case. Every time best partition. Whenever quicksort is going on, right, that itself will call many times. Means partition algorithm is running inside, many times running. Every time best partition happened, then best case. Every time worst happening, right, then worst case. Suppose assume that half time best happened, half time worst happened, then average case. That is the meaning of average case. If anyone asks you quicksort algorithm, what is the meaning of best case? What will you say? Quicksort algorithm, the meaning of best case is going to be whenever quicksort algorithm is running, because of it is a recursive program, same, right, recursive program, same quicksort keep on calling, which is nothing but internally partition is keep on running. Many times partition is going on. Every time, many times partition, every time best partition, then best case. Every time worst partition like this is one, every time worst partition, then worst case. Suppose assume that out of this one, I think out of these many partitions, see here also partition, many times I applied partition. Out of these many partition, half time best partition, half time worst partition, that is called the average case, which is also equal to best case. Please be careful. Partition in the quicksort algorithm going on, partition algorithm many times will happen. Every time partition algorithm doing best behavior, best case. Every time partition algorithm worst behavior, then worst case. But half time best case, half time worst case, that is called average case, which is equal to best case only. Right? Please be careful. That is the reason what I want to say is, after taking the input, apply partition algorithm with one time only, don't stop. By seeing one time, don't say what is going on. Who knows that first time is worst case came, second times maybe best will come, third time maybe worst will come, fourth time maybe best will come. If at all alternatively coming, what is the meaning? Half time best, half time worst, which will goes to best only. Suppose that half time always worst came, remaining half is best came, then also will goes to best case. Until you observe what is going on, don't stop. Some people are asking, sir, if I do like this one, it will take a lot of time, right? Before GATE exam, do as much practice as possible, so that in the exam, very less time you will take. You may say that, sir, before doing also in GATE exam, before GATE exam, if I do lot of practice, in GATE exam also may be required. If really required for everyone same time, what is your problem? For everyone same time, where is the problem? You only taking more time, then only problem will come. Suppose that is a really tough problem in GATE examination, right? Just leave it. What is there in that, right? Because the reason is, out of 100 marks, right? If you see the every year first ranker, second ranker, 10th ranker like that, right? No one crossing more than 90, approximately 85, right? 88, maybe sometimes 84, right? No one crossing. That is the topper itself is getting approximately 90, means in every subject 1 or 2 questions maybe tough may come, 1 maybe. Right? In every subject maybe, I think in few subject tough will come, 1 or 2. That is the reason. Don't worry about that. Practice as much as possible before only. Because of more time and less time, don't give wrong answers. Right? Can you help me? Last question I want to ask you. Quicksort is nothing but partition. Any question is given on the quicksort, partition algorithm, please apply. After applying partition algorithm one time, right? Don't conclude what is going on. Just to do 1 or 2 rounds. In my opinion, 3 rounds you do, you will get some idea. But if you know the idea, starting itself what is going on, one time you applied, you got to know what is going on, then also you can stop. Little doubt also there, 1 more round, little doubt also there, 1 more round. Don't do more rounds, because time also more important. Unnecessarily don't do more time, right? Fine, it's okay. Finally, to this input, how many comparisons? N square. Right, n square. So this kind of tree will come. See this one. Sum of 6 elements are given, sum of 5 natural number. Right, n elements are given, sum of n minus 1 natural number, n square. To this input, if you give this kind of input to the quicksort algorithm, right, it will take comparisons are n square. Everyone now, comparisons are n square. What is the meaning? There is something which is n square. Time complexity definitely n square. Time complexity means whichever is more, that is the time complexity. So n square came. This is the place where quicksort will give worst case. See, the time complexity of quicksort algorithm for this kind of behavior, n square. Why? I think n level tree. See this one, n level tree almost. Every level n time. Why every level n time? You are applying partition. See this one, first level also partition, n time. Second level also partition, n time approximately. Third level also partition, n time. N times n square. Actually, it is not n times n. See this one, 1 time 1, 1 time 2, 1 time 3 and so on. Right? 1 time is n, sum of n natural number, something like that. If I want to say easiest way, this also. First time partition, n time. Second time partition, n time. Like that, n times n square. That is also okay. Okay, I am thinking you are okay. Let's go to the second input. First input you are okay, let's go to the second input. See the second input now, please take care second input also. See this one, this is the second input. Right, this is the second input I am writing now. See, this is the second input. Can you say the second input? This may be the case. 60, 50, 40, 30, 20, 10. 1, 2, 3, 4, 5, 6. 60, 50, 40, 30, 20, 10. Right? This is the input. So to this one, how to if you apply the quick sort on this, how many comparisons it will take? Let me do that also. Let me do. What is the first time? At least you have to do 1 or 2 rounds. Let me check. P here, Q here, I, J, pivot element x is equal to 60. That is also okay. Let's start now. I, right? I, J. Right? So like this is the current status. Now let me check here. I'm starting. So J is asking this person, are you greater? No. Then increment and swap itself. Same again. Right? Swap himself. See, previously no swap at all, now swaps are there. Can you help in why every time swap is coming? Can you help in elements are in the increasing order or decreasing order? Decreasing order. What is the meaning? If you go further, all are small coming. Every time small means every time I will move. Previously increasing order, every time greater is coming, no swap. Now here every time smaller is coming, every time swap. You know partition algorithm very well, I am doing that only. J is going out, right? Whenever J is out, stop. Now partition algorithm, right? In the partition algorithm, for loop is over. For loop is over 3 parts. P and next one is going to be until I small. Afterwards, bigger, no one is there which is bigger, see this. Right, previously no one smaller, now no one is bigger. Right, next one, swap A of P, A of I, swap it. Here 60, here 10. Right, see this one, see actually it is the decreasing order, right, finally, right, what happens because of all smaller, I went here, finally swap A of P, A of I, next one, return I, what is I value? 6. Now, let's see what is the output here. Partition algorithm on 6 people I applied. How many comparison? 5. Because comparison will start from second element. Right? So 5 comparison. Let's write the output. What is the output here? 10, 50, 40, 30, 20, 60. And one more. Pivot element went to which place? 6th place. 1, 2, 3, 4, 5, 6. 6th place pivot element went. Less than pivot one side, more than pivot no one. See, here right gap. In the previous input, where is the gap? Left gap. Here, right gap. So, left gap, right gap doesn't matter. Previous one is given worst case behavior, one side gap. Now, this is also looking like worst case behavior. By seeing one time partition, you cannot. What is the reason? Half time best, half time worst also best only. I think this is the worst. Who knows that next maybe best will come. Next maybe, but if you know what is going on, you can stop. Right? If you don't know, let's see one more round. I am thinking, by seeing this one, I got to know what happened. See this one. Because of all are smaller, I went here. Lastly, 60 will go swap like that. Right? Now see what will happen. So on this one, if you apply partition algorithm, careful listen. On this one, if you apply partition algorithm again, right? Partition algorithm on 5 people. How many comparison? 4 comparison. It's okay. Let's start. P here, Q here. I, J. Now see the answer. J is asking. Carefully listen. J is asking. Are you greater? Yes. It is the pivot. Are you greater? Yes. Are you greater? Yes. Are you greater? Yes. So crossing is there. Next one, lastly, because of I is not moved. Swap A of P, A of I. Swapped himself. Then return I. What is the I value? 1. Now let me write the output now. Let me write output. What is the answer? 10, 50, 40, 30, 20. 1, 2, 3, 4, 5. Can you switch the pivot element return? 1. So 1 will go here. Right? Now do you believe or not? In the second round, left gap. In the first round, right gap. In the second round, left gap. That is the reason I am saying to you. Right? By seeing the first one itself, if you conclude, some problems may come. Especially in the gate examination. Right? Little bit time you take at least. If you do lot of practice before gate examination, by seeing problem, you will give the answer. Right? Fine, anyhow. So I think by seeing the first one and second one, I got to know one interesting thing. What is this one? See this one. Initially, right, all elements are there in, see this one, decreasing order. After one round over, see this one, smaller one came to first place, right? First one will go to last place. Then this kind of behavior. Then what will happen? It is looking like, see this one, it is looking like 10 followed by all are greater. It is looking like previous input. This is the smaller one among all the people. So then left gap came. But if you see now, again decreasing order. Because of you swapped, right? First smallest element came. That is the reason left gap. Right? Now if you see, right? I think again decreasing order. Again first one will repeat. If you want, you can check. This one, partition algorithm, if you apply on 4 people, 3 comparisons. Right? Now what is the answer? If this is the pivot, all will be smaller. Every time swap himself. Every time swap themselves, right? After crossing over, what is the answer? Right? So I think I will be here, J is out, swap A of P, A of I. What is the answer? 20 here, 50. See this one, larger one will go there, smaller one will come here, right? Now what is the answer? 20, 40, 30, 50. You know very well, 50 is a pivot element, right? It went to the correct place. Less than 50, these many people. More than 50, no one. Now again right gap, but one thing, again right gap, it's okay because of swapping. Next level again, smaller one is a pivot, then left gap will come. If you see this one, partition algorithm on, right, 3 people, 2 comparisons, right? Now 20 is the pivot, less than 20, no one, all are more than 20, 40, 30, right? Now again left gap, it is going on like this. So alternatively, this is going to be alternatively. Some people are asking, sir, what kind of tree will come? I will write roughly tree also, please check. Roughly I am writing the tree also. See everyone, see. 6 elements are there. If you apply partition algorithm, first time which side is gap? Right gap. What is the meaning? 5 here, 0 here. But comparisons are 5. Same, what about 5 here? Right, left gap now. 4. I think, what is the answer? Comparisons how many? 4. What about 4 here? What is the answer? I think it is going to be, this side is going to be 0, this side is going to be 3, I think 3 comparisons, right? What about this one? Same, 0, 2, it is going to be 2 comparison. This one, what is the answer? 0, 1 comparison. 1 element means stop. If you see, if you add all of them, what is the answer? 5 comparisons here, 4 comparisons here, 3 here. Same story. Sum of n minus 1 natural number. Same reconciliation, same thing. Tn is equal to comparisons. Right? Finally, it will goes to n minus 1 plus n minus 2 plus and so on 1, which will goes to sum of n minus 1 natural number. Big O of n square. This is also n square. Can you help me? What kind of tree coming? In the previous tree, first input tree, if you observe, right, always left gap. But here alternatively, one time left gap, one time right gap. And one more, if you apply partition algorithm, directly partition algorithm only deciding. Some people are asking, sir, partition algorithm, if I apply many times, it may take time and all, right? Just in my opinion, if you get first round itself, what is going on, right? Clear clarity there, first round itself, what is going on, you can stop. If you have doubt, next round. 3 rounds is more than enough. Then you will get to know what is going on. From that you can conclude. So first input is left gap, second one is going to be, right, one time left gap, one times right gap. See, right, left, like that. But one thing, comparisons are who bother about which side is gap. First one also worst case behavior, second one also worst case behavior. Let's go to the one more. Third input also, let me check. I am checking third input also. Can you help me know what is the third input? See, it is a very interesting one. Please see this one, third input. Can you see third input purpose? What is the third input here? All are same. Let me write all are same. 10. All are same. So because of all are same, you may be having some small confusion. So let me give you some hint also. See, it is the first 10, it is the second 10, it is the third 10, it is the fourth one, right? So it is the fourth 10, it is the fifth 10, it is the sixth 10. Totally 6 10s are there. First 10 is the 10A, last 10 is the 10F, 10A, 10B, 10C, 10D, 10E, 10F. Right? Now one more. The greatest advantage with this input is going to be, one round of partition is enough because all same. All same means same behavior will happen. Let me do one round. One round enough. How one round? See, start. P here. Indirectly, directly partition algorithm. Please practice partition algorithm. Different books are having different partition algorithm. All will do indirectly, directly this only. This partition algorithm you follow. It is enough. I, J. What is the pivot element? 10A. What is the meaning of 10A? In the input, right? This 10 came first. In the input, 10F came last. Please be careful. So, P, Q, I, J. I think J will start. See this one? Can you help me? What J will ask? J will ask one question. What is that? Are you greater? He said, no, I am not greater, I am equal. So, I think smaller or equal. Definitely I will come. I will come here. Swap himself. 10B. Again, are you greater? No. Swap himself. Next one, are you greater? No. Swap himself. Next one, are you greater? No. Swap himself. Next one, are you greater? No. Swap himself. Right? J crosses the boundary, then for loop is over. Whenever for loop is over, what is the next step? Swap A of P, A of I. I think I is there in the last place. Swap them. Then what is the answer? This will become 10F. This will become 10A. Not only that, at which place you kept pivot? 6th place. It will return also. 6 will return. Now let me write. Partition algorithm on 6 people. How many comparison? 5. That's okay. Let me write the output. What is the output? Check. 10F. 10F. Next. 10B. 10C. 10D. 10E. 10A. And one more. Which place he went? 6th place. So, 6th place pivot element there. Let me give positions also. Less than or equal to pivot left side. More than pivot right side. A right gap. A right gap. One time partition algorithm I applied. I got to know that this input will give always right gap. What is the reason? All elements are same. No need to go further also. But one more thing I want to ask you. See this one. One more thing. Always right gap will come. Every time see this one. Every time right gap is there. So I think again n level tree will come. Same kind of behavior. But one more interesting thing I want to say to you. Carefully listen. Carefully listen. Can you help me now? After partition algorithm is over one time. After partition algorithm is over one time. Who sorted? Partition algorithm is over. Who sorted? Everyone now. Pivot element sorted. What is the reason? After partition algorithm is over, pivot element will go to correct place. What is the meaning? It is sorted. Who should sort further? Left people should sort, right people should sort. What is the meaning? 6th person is already sorted. Means you don't change further. Indication that, right? So see this one. Less than this one, less than or equal to these many there, right? Afterwards it will come. Now it is the correct time to ask you. It is the correct time to ask you. Pivot element is already sorted or not? Yes. Now can you help me? If it is already sorted, right? What about before? They will sort afterwards. But one thing, this position cannot change. Then what is the meaning? In the sorted array, see this one, in the sorted array, 10A went to the last. But in the input, 10A is there in the first. What is the meaning of 10A? In the input it is the first 10. But in the output, it became last 10. That is the reason quicksort is not stable. In the input first 10, right? In the output it is looking like last 10 because after sorting, he is already sorted. Pivot element already sorted. Total array may not be sorted, but pivot element already sorted. Before should sort, after should sort. Means he is already sorted. What is the meaning? It is there in the last place. It is the first 10 in the input. In the output it is the last 10. What is the meaning? Repeated elements order is changing. So quicksort is not stable. Quicksort is not stable. From this example you can say quicksort not stable because repeated element order may change. The reason is going to be 10A in the input first place, but 10A in the output last place. Repeated elements order is changing in the output. So I can say that quicksort is not stable. So let's see the number of comparisons. I think you are okay. Let's see how this one diagram look like this. 6 elements. Always right gap. 5 here, 5 comparisons. Next one, 5 elements, right? So right gap, 4. Here how many comparisons? 4. What is the answer? Right gap, 3. This is going to be 3 comparisons. It will continue like this. So I think 5 plus, 4 plus, 3 plus and so on. 2 and 1 will come. Similar way, same story. Tn is equal to number of comparisons. right? Then it will goes to n minus 1 plus n minus 2 plus and so on 1. Finally, sum of n natural number n square, right? Like this. Can you help me now? First input number of comparison. Let me simply, I am minimizing it. I am minimizing. Let me minimize this. See this one. It is the first one. It is the first one. All three I want to keep in one page. Let's check. See this one. It is the first one. First one, if you observe, number of comparisons are n square. Second one, if you observe, number of comparisons are n square. Third one, number of comparisons are n square. All three are equal. Because of everyone, time complex means whichever is more, that is the time complexity, right? If the input is like this one, time complexity n square, y, comparisons are n square. If the input is like this one, time complexity n square, y, comparisons are n square, right? Please be careful, right? So all three will take time complexity n square. What are the, right? These are the worst case scenarios. See this one. If you give this kind of input, worst case will come for the quicksort. If you give this kind of input, worst case will come for quicksort for all the. So can you help me now for this problem? What is the final answer? What is the final answer you want to say? Let me check here. What is asking? See in this problem, what is asking? Check. This is the problem. Let C1, C2, C3 be the number of comparisons. So he is asking, then what will be the relation between C1, C2, C3? What is the answer? C1 is equal to C2 is equal to C3, right? Please be careful, right? These many comparisons are there. So I think these three inputs, if you give to the quicksort, right, it will take worst case n square, right? Now it is the correct time to ask. Please listen. Listen, it is a very, very important point is coming. Can you help me now? To this problem, what is the answer? All three equal. I am okay with that. So that is the correct answer. Fine. Now see this one. One very, very important point is coming. Please listen. Quicksort algorithm will give for these three people worst case performance n square or not? For these three inputs, quicksort algorithm will give worst case performance n square. Everyone know that. Please remember, quicksort algorithm will give worst case performance. Quicksort algorithm will give worst case performance. Very rare incident. That is also if array already sorted. Quicksort algorithm will give worst case performance. Very rare incident. That is also if array is already sorted. See this one. I think first input if you see ascending order, second input if you see descending order, third input if you see equal, means all three are sorted order. If array already sorted, quicksort algorithm will give worst case performance. Please be careful. Quicksort algorithm will give worst case performance. Now some people are asking, sir, quicksort algorithm, forget about which time it is giving worst case, but worst case is there or not? Try to remember. If array is already sorted, then quicksort is giving worst case performance. If already sorted, why are you sorting? Quicksort algorithm give worst case performance n square. I am okay with that. When if array already sorted, why are you sorting? What is the reason? If array already sorted, you are sorting means you are mental, right? You only say already sorted, why are you sorting? Are you mental? Quicksort is saying that if I ask the quicksort, you are giving worst case n square, how can you say that you are a great algorithm and all? Quicksort simply saying that I am giving worst case n square, because you are mental. You may say that, sir, how can you talk like this? You may say like this one. Quicksort is saying that I am giving worst case n square, it's okay, right? The reason is you are mental. The reason is going to be, if array already sorted, why are you sorting? Now that is the reason I said to you starting of the quicksort. What I said? Quicksort is practical sorting algorithm. What is the meaning? If you really need sorting, then only go to quicksort. For the namesake purpose, already sorted, you want to sort, please don't go that kind of time. It is not normal sorting algorithm, it is a practical sorting algorithm. Means if you really need sorting, he will help you. If at all really don't need sorting, still if you are applying, he will blame you by giving n square. Simply he will say that I am giving n square, I am not the reason, you are the reason, because you don't know when to apply sorting algorithm. Now final conclusion, forget about all whatever I said. Final conclusion, quicksort algorithm will give worst case performance when if array already sorted or almost sorted. What is the meaning? In the given array everyone sorted except one or two people. Always remember, one or two people cannot do anything. Majority people what? If majority people sorted, quicksort algorithm will give worst case performance. If majority people not sorted, what is the meaning? Random array. In the given array, right, most of the elements are not sorted. What is the meaning? All are random places. Then quicksort will give best answer n log n. Can you help me? Again I am asking you, quicksort algorithm will give worst case performance when if array already sorted or almost sorted, quicksort algorithm will give worst case n square. When the in other cases other than this quicksort will give best case performance or average case performance n log n. Please remember it. Please remember, it is a practical sorting algorithm. What is the meaning? When you really need it, it will give best answer. When you don't need, right, if you want to blame him, he will blame you back by giving n square, because it is a practical algorithm, right? Fine. To this problem, answer is all three equal. From this, the conclusion is quicksort will give worst case if array is sorted or almost sorted, answer is n square. In other cases other than this, means array is not sorted, most of the elements are not sorted, then quicksort will give best answer n log n, which is the average case and best case. Fine. It is a really nice problem. Please you take care. Can you help me from this problem? Final conclusions, what you want to say? Any problem is given for quicksort algorithm, right? Without thinking that much, partition algorithm you apply. After applying partition algorithm, right, if you are unable to conclude what is going on, don't do blindly. If you are unable to conclude what is going on, apply partition algorithm, right? Second time also, third time also, maximum 3 times you do, you will get some idea. But one thing, indirectly, directly they are applying partition algorithm only in this problem. This is a nice problem, 5 times came, please you take care. One problem I done, almost you got the clarity, many times I repeated also. Please see that problem. See this one. Time complexity of the quicksort Tn is equal to, can you say first step else part? Time complexity of quicksort Tn is equal to, right? Can you say in the else part first step, right? Apply partition n time. After partition algorithm is over, n time is over, if you are lucky, what will happen? Partition algorithm is over, n time is completed. If you are lucky, what will happen? It may divide the array into balanced partition. What is that one? Tn by 2, Tn by 2. Balanced partition, right? So, time complexity of the quicksort Tn is equal to, apply partition n, because of you are lucky, best partition happened. Right? Now, can you help you know? How will you solve this kind of recurrence relation? More than one recursive call there. Recursive tree method. Let me do recursive tree method roughly. You know very well. What is the recursive tree method? See this one. N elements. You know very well. N elements, right? It will take n time. N elements, it will take n time. N elements, it will take n time. Divide into 2 parts. What is that one? N by 2, n by 2. N elements, it will take n time. Partition algorithm divide into 2 parts. N elements divided into 2 parts, division time is n time. Similar way here, n by 2, it will take n by 2 time, because n means n time, n by 2 means n by 2, right? So it is going to be n by 2 square, n by 2 square. Same thing here, n by 2 will take n by 2 time, 2 parts, n by 2 square, n by 2 square. Can you help me now? Second level, if you add, what is the answer? N by 2, n by 2, 2 n by 2 means n. First level, second level, same means everywhere same is coming. And one more, always you are dividing, see this one, left always divide by 2. How many levels? Log n levels. Left always divide by 2, log n base 2. Right also always divide by 2. What are the levels? Log n base 2. Both the sides same levels will come. It is a balanced tree. Every level is n, like that, left also log n, right also log n. So total answer n log n. Right? So everyone now, the answer of this one is going to be how much? N log n. Quicksort, I am repeating once again, one nice point coming, please listen. Quicksort algorithm time complexity Tn is equal to, first apply partition n. If you apply partition algorithm, n time is over, it divides the given array into 2 parts. Assume you are lucky, best partition happened, n log n, 50-50, n log n. Why n log n? Always divide by 2, n log n base 2. Always divide by 2, log n base 2. So left height also log n base 2, right height. And one more, first level cost is n, second level also if you add both, one more n. So first level, second level same means everywhere same. So n into log n log n. I am thinking you are okay. Let's see the one more interesting line. See this one. Time complexity of the quicksort Tn is equal to, see everyone, apply partition n time over. Apply partition n time over. Now see the answer. If you apply partition n time is over, okay, then partition algorithm dividing the given array into two parts, but it is dividing like this. See this one. It dividing like this one. T n by 5 is one side, remaining T 4n by 5 is another side. It dividing, see this one. It is dividing the given array into two parts, not one side 0. Right? So it is not dividing balanced way, but some elements this side, some elements this side. Right? n by 5 elements one side, 4n by 5 elements another side. Suppose that n value 100. What is the 100 by 5? 20. N value 100. 100 by 5 is 20. Right? Left 20 people, right 80 people. It is not balanced division, it is unbalanced division. But one thing, right? Some side is some elements are there. It is not completely unbalanced. Few elements this side, one side is 20, one side is 80 you are keeping. Some elements are there, that's fine. Suppose isn't that partition algorithm dividing equally n log n k. Suppose isn't that it is dividing like this one, n by 5 one side, remaining 4n by 5 other side. Can you help me know what will happen? Let me check. Can you help me know? N elements n time. This reconciliation I am solving. Right? N elements n time. That is okay. Divide into two parts. What is the first side? N by 5. Next to 4n by 5. Right? In the next level if you see, n by 5 will take n by 5 time, 4n by 5 will take 4n by 5, it's okay. It divide into two parts. If you add these two, n by 5, 4n by 5, again n will come. So, first level, second level, third level, everywhere n will come. First level, second level same means everywhere same. Every level cost same. But one thing, left always divide by 5, log n base 5 will come. Right always divide by, left divide by 5. Right divided by 5 by 4, multiplying by 4 by 5 means divided by 5 by 4. So, right is going to be log n base 5 by 4. Left is going to be log n base 5 levels, right is going to be log n base 5 by 4. Can you say log n base 5, log n base 5 by 4, who is bigger? Log n base 5 by 4 bigger. So, finally what is the answer? N into log n base 5 by 4. It is upper bound. What is the lower bound? We go of n log n base 5. It is the lower bound. Lower bound means omega. Because both differ by only constant, you can write theta also, theta of n log n. You know very well how to solve this reconciliation, don't worry. Using recursive tree method, you solve it. Can you help me now? Left height, always divide by 5, log n base 5. Right height, log n base 5 by 4. Which one is larger? Log n base 5 by 4. So, every level cost is n. First level n, second level also n there. Every level cost is n, right? Upper bound is log n base 5 by 4. Final answer is going to be, you can write theta here also, n log n base 5 by 4. Actually, it is a big O, right? If I write the base 5 omega, because of big O omega, both possible theta, because these two difference by constant only. Left and right differ by only constant. If you want, you can write theta also. Now, I think it is the correct time to ask you. Please listen. Until now you are thinking that quicksort algorithm will give best case performance or average case performance if equally divided. Need not be. If it is divided like this, then also n log n. If anyone having small doubt, how will you solve this one? Recursive tree method, please practice. Recursive tree method I done because of I done fastly. Please be careful. Can you say left height log n base 5, right height log n base 5 by 4, upper bound log n base 5 by 4. Every level cost is n, log n base 5 by 4. So, n log n base 5 by 4, it is the upper bound actually. Right? Omega, if I write, here base 5 will come. Both differ by only constant, theta I can write. Next one, let's see the one more interesting story. See this also. Time complexity of the quicksort Tn is equal to n for partition. After partition algorithm is over. Right? Your array will be divided into like this one. N by 3 one side, T 2n by 3 is other side. Right? So, if you want, you can solve this one. Suppose that n value 99, 99 by 3 33, 33 one side, 66 is other side. Right? This will also leads to, right, n log n time. Check yourself. Next one more. Because of you are really comfortable, see this also. Time complexity of the quicksort Tn is equal to n for partition, right? Tn by 10 plus T 9n by 10. Right? If you solve this reconciliation, if you want, you can check n log n. This is also taking n log n. This will goes to log n base 10. This will goes to log n base 10 by 9. Upper bound is log n base 10 by 9. So, n log n base 10 by 9. So theta also you can write because differ by only constant only, right? I think by seeing this one, all the people got one interesting line. What is that one? To write Quicksort algorithm will give best case and average case, not only 50-50. See this one, not only 50-50. This also see. Out of 100 element, 20 one side, 80 another side. I am repeating once again, out of 100 element, 20 one side, 80 other side. Then also best case, average case. Next one, out of 99, 33 one side, 66 is other side. Then also best case and average case coming. Out of 100 people, 100 by 10 people one side, 90 people other side. Then also Quicksort will give best case and average case. Until now people are thinking that, Quicksort will give best case only 50-50. No, need not be 50-50. See this one, it is almost like, see, 1:4 ratio. Out of 5 parts, 1 part is this side, 20. Remaining 80 is this side. Next one, out of 3 parts, right? 1 is this one, 2 this side, 1:2 ratio. See this one, out of 10 parts, 1 here, 9, 1:9 ratio. So what I want to say, need not be 50-50. Right? Like this also, Quicksort will give best case and average case. That is the reason I am saying to you. Quicksort most of the time will give best case or average case. Very rare incident, Quicksort will give worst case, right? Previous problem I explained to you. Array already sorted or almost sorted, then only Quicksort will give worst case, right? Remaining all the cases, it will give average case or best case. So this is the example, see. If I don't, listen, if I don't say this story, you may think that Quicksort will give best case only for first case. No, these also, I am writing now, right? These all for best case and average case. Quicksort will give average case and best case in all these cases, right? Please be careful. If I don't say, you may think that first only best case and average case. No, right? These all will give, these kind of all things will give best case and average case. Now, by seeing all, I am giving one generalized one. See this one. When Quicksort will give best case and average case, by seeing all, one generalization I am giving. See this one. It is a very interesting one. See, Quicksort time complexity Tn is equal to, careful listen. Quicksort time complexity Tn is equal to, first apply partition n plus. Quicksort time complexity Tn is equal to, first apply partition n plus. Next one, right? See this one, n plus, after partition algorithm is over, partition algorithm dividing the given array like this. How? See this one, like this. How? T alpha n elements one side plus T 1 minus alpha n is other side. Right, after partition algorithm is over, n time over, then array will be divided into like this. How? T alpha n elements one side, T 1 minus alpha n is other side. If this kind of division is there, then Quicksort algorithm will give, right, best case or average case, which is n log n. Where some people are asking, sir, what is the alpha? Where alpha is one, where alpha lies between more than 0, less than 1. What is the meaning? Fraction. Alpha is a fraction. Please be careful. Some people are asking, sir, alpha is a fraction means what? That may be 1 by 2, that may be 1 by 5. Suppose if I take alpha value 1 by 2, if I take alpha value 1 by 2, it will become T n by 2, T n by 2. I think first case will come. If I take alpha value 1 by 5, second case will come. If I take alpha value 1 by 3, third case will come. If I take alpha value 1 by 10, right, fourth case will come. It is a generalization. This is the recurrence relation for Quicksort, best case and average case. Please be careful. Where alpha is a fraction, what is the meaning? More than 0, less than 1. So this is the, listen, please be careful. Until now you are thinking that Quicksort will give best case only 50-50, need not be, right, like this. And one more, please help me now. Alpha value, see this one. If alpha value, careful listen, if alpha value is 1 by 2, alpha value is not 2. If alpha value is 1 by 2, right, what is the height of this stack? Log n. See this one. If alpha value is 1 by 2, right, stack size is going to be log n base 2, right. So I think it is going to be log n base 2 if you want, but alpha is 1 by 2, right. You cannot write alpha, log n base 1 by alpha. So the height of this one is going to be log n base 1 by alpha, where alpha is 1 by 2, it will become 2. Can you say what is the height of this one? Suppose isn't it 1 minus alpha is isn't it 4 by 5, right? I want log n base 5 by 4 means 1 by 1 minus alpha. So the height of this one is going to be log n base 1 by alpha. The height of this one is going to be log n base 1 by 1 minus alpha. Both are similar, right? The only thing is constant factor they differ. Now can you help me once more? Which one is larger? First one or second one? Right? Both are log n only, it's okay. Right? Constant factor they differ, it's okay. Can you help me in these two people, which one is larger? Please help me. Log n base 1 by alpha, log n base 1 by 1 minus alpha. Who is bigger? Whoever is bigger, that is the upper bound, which is called as stack space, which is called as maximum. Everyone, the depth of the stack means is going to be, right, maximum levels. Right? Can you help me now? Log n base 1 by alpha, log n base 1 by 1 minus alpha. Who is bigger? Let me know. Who is bigger? Suppose in that alpha values, assume that alpha value isn't that, right? 1 by 5, it will become 5. It will become 5 by 4, then he is bigger. If alpha value is 1 by 5, this is log n base 5, it is the log n base 5 by 4, then he is bigger. If alpha value is 1 by 5, then he is bigger. If alpha value is 4 by 5, this is log n base 5 by 4, it is become log n base 5, then he is bigger depending upon alpha. Can you help me now? This one and this one, who is bigger depending upon alpha? If anyone take alpha 1 by 5, then he is bigger. If anyone take alpha 4 by 5, then he is bigger. So when you don't know who is bigger, just say maximum of. Maximum of this one is going to be depth of the stack. Everyone, depth of the stack means stack units how many you are taken, right? Supposing that this one is smaller, that one is bigger, stack units are these many. Supposing that this is smaller, this is bigger, stack units are these many. I don't know who is bigger, maximum of these, right, is going to be depth of the stack. So some people are thinking that, right, this is the maximum. They are thinking like this one, depending upon alpha. Alpha 1 by 5, this is bigger. Alpha 4 by 5, then this is bigger. Maximum of these two is going to be depth of the stack. And one more thing I want to ask you, time complexity for best case and average case, everyone know n log n. The only purpose of this debate is going to be, until now you are thinking this only best case. No, these also best case and average case. In general, like this. Now can you help me now? Normal English line can you say? Normal English line can you say when the quicksort algorithm will give best case or average case? When the quicksort algorithm will give best case or average case? When, right? It is like this one. When the quicksort algorithm will give best case or average case is going to be, right, array is completely random, then this kind of behavior you can expect. Completely random, right, almost random also, okay, this kind of behavior you can expect. Best case or average case, quicksort will come, right, fine. Partition algorithm should have what kind of behavior so that, right, it will give best case or average case, right? Very simple answer. Partition algorithm should divide the given array in such a way that fraction of n one side, that something like n by 2, n by 3, fraction of n one side, remaining other side. If the partition algorithm will do this kind of division, it will give best case or average case. I am repeating once again, partition algorithm should have what kind of behavior so that it will give best case and average case. Answer is going to be, partition algorithm should divide the given array in such a way that fraction of n one side, remaining other side, then quicksort algorithm will give best case or average case, right? The same thing I said in English lines now, same thing I written technically like this. Fraction of n one side, remaining other side. What is the meaning of fraction of n? Alpha. Alpha n one side means fraction of n one side, remaining is other side, then quicksort algorithm will give best case or average case. Right? If partition algorithm dividing the given array in such a way that fraction of n one side, remaining other side, then quicksort algorithm will give best case and average case, which is n log n. See, it is a nice debate, please take care. If I don't say, then also okay, but some cases missed out. This one, listen, before this debate, you know first line only. Now after this debate, you got to know, these all will give best case or average case. These all, what is the meaning? Fraction of n one side, remaining other side. Then, can you help me know what is the depth of the stack here? Log n base 1 by alpha, log n base 1 by 1 minus alpha. I don't know who is bigger, maximum of. That is going to be depth of the stack. Fine, I am thinking that you are really comfortable, right? Let's see one more small line. See the one more small line. See everyone, one small line pending. See this small line. Can you help me now? See this one interesting line is coming. This also you take care. Tn is equal to time complex of the quicksort. Tn is equal to, first apply partition. Yes. After partition algorithm is over, if you are unlucky, what will happen? Left 0 elements, right how many? Out of n people, partition algorithm is over means pivot out, remaining n minus 1. Left 0, right is n minus 1. Right? Can you help me one small line now? Right? See, forget about because of t of 0. 0 elements, right? Everyone now. Constant element, constant time. Don't bother. Constant elements, constant time. Don't bother this one. Remaining. So what is the answer? Always you are decrementing by 1, by 1, by 1. What is the answer? How many level tree will come? N by 1 level. Everywhere n time. If you want, you can do recursive tree method also. Same thing. So always minus 1, minus 1, minus 1. N by 1 level tree will come. Everywhere partition algorithm. N. So n square. Everyone, a quicksort algorithm, worst case this only. This one, on n elements, quicksort time complexity Tn is equal to apply partition n. Unfortunately, worst partition, 0 elements one side, remaining other side. Next one, because of 0 elements, 0 time, forget about constant elements, constant time. So this only take care. Always you are subtracting 1, 1, 1, right? N by 1 level. Everywhere partition algorithm is n time, n by 1 into n, n square. Fine, that is everyone know. You know this already, right? See the interesting answer. Time complexity of the quicksort Tn is equal to apply partition n plus, right, n time over. Assume that you are unlucky. This may be the case happened. Can you help me? Partition algorithm is over means 1 element out. Remaining is n minus 1. Out of those n minus 1 people, 1 person on the left. Out of those n minus 1 people, 1 person on the left, remaining n minus 2 elements on the right. Right? After partition algorithm is over, 1 is out, remaining n minus 1. In those n minus 1, 1 left, remaining n minus 2 right. Now see the interesting answer. Because of 1 element, constant elements, constant time, leave it. Right? Remaining, if you observe, n plus n minus 2. Always subtracting 2, 2, 2, 2, n by 2 level tree. Everywhere partition is n. If you want, you can do recursive tree method. I don't have any objection. It will go to once again order of n square. Next one, because of you are really comfortable, see this also. Time complexity of the quicksort Tn is equal to apply partition n. Because of you are unlucky, right? Partition algorithm is over means 1 element out, remaining n minus 1. Out of those n minus 1, right? Try to remember this one. See this one, 9 elements here, 9 elements left side. Can you help me? 1 is pivot already, 9 elements left side, totally 10 elements, right? Remaining n minus 10 is other side. Out of n people, partition algorithm is 1 is out, remaining n minus 1, 9 people left, remaining n minus 10 is right. Next one, because of this constant people, constant time, if you want, you can do recursive tree method also, no problem, right? Remaining, if you observe, always subtracting 10, 10, n by 10 level, everywhere partition algorithm n, so big O of n square, right? Please be careful. Now, by seeing all, please help me, right? Until now, listen, if I don't say this example, you may be thinking that quicksort algorithm will give worst case. Only for one side is completely gap, need not be. Completely, one side is gap means constant elements one side. Partition algorithm, listen everyone, quicksort algorithm will give worst case performance. If one side is, see this one side is gap means constant elements one side. Constant elements one side, remaining other side, quicksort algorithm will give worst case performance. Let me write the in general, see this one, in general, quicksort algorithm will give worst case like this one. Tn is equal to, after partition algorithm, n time over, right? So n time is over, one pivot element is out, remaining n minus 1. In those n minus 1, see this one, in those n minus 1, assume that c minus 1 people left, right? One is pivot, including pivot and this one. What is the answer? C people one side, right? Remaining n minus c is other side, where c is constant. Can you help me now? C minus 1, 1 pivot. C minus 1 plus 1 is c. C elements, right? Including pivot, c elements one side. Remaining is other side. Because of c is a constant, where c is a constant. Let me write, where c is constant integer. That is okay. And one more, c is greater than or equal to 1. Where c is constant, it cannot be fraction, everyone know. Where c is constant integer, constant but integer. C is greater than or equal to 1, minimum is 1. If the c value is 1, 1 minus 1, 0. It is the t of 0, this will goes to n minus 1. I think first case will come, right, like that. Can you help what is the answer for this one? Because of constant people, constant time, leave it. See this one, every time c subtracted n by c level, everywhere partition n time, order of n square. Right? By seeing all these examples, can you help from today onwards, if anyone asks you, when quicksort algorithm will give worst case, what is the answer? When the quicksort algorithm will give worst case is, after applying partition algorithm, then array will be divided into two parts in such a way that one side constant elements, other side remaining elements. One side constant elements, other side remaining element. Quicksort algorithm will give worst case performance, order of n square. Can you say how many level tree for this one? N by 1 level, n by 2 level, n by 10 level, n by c level. Some people are asking, these many level means that much stack required. So n level stack required. N level stack, but quicksort is not in place. N level stack means extra space n. So using efficient algorithm, they converted this n and that log n. Alright, overall they converted into minimum is 1, maximum log n. So quicksort is going to be a in place algorithm. Right, fine. I think efficient algorithm, if you write space, you can save. How much you can save? Stack space of the quicksort is going to be minimum 1, maximum log n. Like that you can save. That is the reason you don't worry. Fine. So listen everyone, if I don't say this story, you may think that quicksort will give worst case only first case. No, many cases. Conclusion, constant elements one side, remaining elements other side, quicksort will give worst case. Let me write. Worst case of quicksort is this one. Worst case of quicksort is this is the story. Now please help me now. When the quicksort will give best case, what is the answer? Partition algorithm dividing the given array in such a way that fraction of n one side, remaining other side. Fraction of n, not constant. Constant one side, remaining other side, worst case. So this will cover all the possibilities. Please be careful. Either constant is there, fraction is there, what is there in that? Right? Fine. So these are the things. And one more, some people are asking, sir, this kind of combination when will happen? Array is almost sorted or already sorted? If already sorted, this kind of behavior will come. If almost sorted, almost means what? Except constant people. Remaining all are sorted. Except constant people. Remaining all. Except constant means constant people one side, remaining other side. So this combination will happen, right? If array is sorted or almost sorted, this is the story. Right? This kind of combination will happen. This kind of combination will happen. Right? Array is this one. What is this one? This kind of combination will happen. Right? If random array or almost random. Random array or almost random. This kind of behavior will happen. Fraction of n one side, remaining is other side. One more thing I want to say to you. Before starting the quicksort algorithm, right? You may not know these many things. Now almost many things you got. 3 hours I explained the quicksort algorithm from starting to until here. Please check. Clearly I explained to you. Can you help me in the quicksort? What is the first thing I explained? Partition. Partition if you are okay, right? Based on partition, right? Quicksort algorithm I written. I analyze it also. Next one, afterwards I given one numerical example and all, right? C1, C2, C3 like that. Next one is this one. This is a really nice debate. Please take care. Some people are asking, sir, can't I read book? You can read. This, the thing, whatever I covered all, right? It is a combination of 10 books. It is a combination of so many video lectures in the YouTube. So, why you want to do the same thing again? Then what you are learning? What is the meaning of inheritance in the computer science? Inheritance is nothing but, right? You have to inherit from your seniors, from your parents, right? So, already they done something. Why you want to do same thing again? So, please learn from the, right, your seniors. Right? I am like your senior. You learn something from your family, right? You learn something from me. I done a lot of work. Why you want to read again? Right? This entire story, please check once again. 1 or 2 points are there. Maybe book you can read, right? Maybe in the YouTube you can verify. Same video once again you can check. Below video some comments are there, right? Comment section you can post, right? Like that you can ask your friends. Small things only people will help. Please be careful. After watching the video, if you write below, explain the video, who will do that? Right? It is not possible at all. I want to do, but it is not possible. If you ask your friend, explain the total quicksort, no one. Do 99% or 95% from you. Small thing, you can take help from your seniors and like that. Right? Fine. It is a nice debate. Please take care. I am not saying that these are not there in the right YouTube and all. It is there. You have to find out first which one is the best video. Whether whatever he is saying is right or wrong. Right? Why you want to do that? I done lot of times. Right? First ranker I explained, second ranker I explained. He said something, I said something. Right? Some nice conclusions. I learned so many things. I am sharing that knowledge to you. Right? Try to get as much as possible. Right? Fine. So, see the next problem of the quicksort. One problem we are already done, right? See the next problem. Right? I am reading this problem. Read it. In quicksort, the sorting of n numbers, the n by 5th smallest element selected as a pivot using order of n time complexity algorithm. Then what will be the worst case time complexity of quicksort? Right? He want to say simply one small line. What is that? Normally we will take first element as a pivot. What is the time complexity? You know very well. What is the time complexity? If you take first element as a pivot, if you apply the quicksort algorithm, what will be the time complexity? Best case, average case n log n, worst case n square, you know very well. But now what he is asking is, if you take n by 5th smallest element as a pivot, right, what will be the worst case time complexity they are asking. How to solve this problem? I will explain. And one more. In the normal quicksort algorithm, whatever we studied, right, previously, in the normal quicksort algorithm, which element you will take pivot? First element. Taking the first element as a pivot, how much time? Right? You know, x is equal to a of p, no loop, nothing, constant time. Right? In the normal quicksort algorithm, whatever we studied, taking first element as a pivot, constant time is the time complexity, everyone know. But in this problem, he is taking n by 5th smallest element as a pivot, which will take time complexity how much? Order of n time. Right? In this problem, he is taking n by 5th smallest element. Because of n by 5th smallest element, you know, first smallest element itself is order of n time. Because one scan required, n by 5th smallest element, he may be done some work, some other algorithm, right? So, n by 5th smallest element he computed as pivot element, right, by taking order of n time, right, something like that he said. Then he is asking what is the time complexity of the quicksort algorithm, worst case. I will explain, please carefully listen, it is a nice problem. Like this, many problems will come in the GATE exam. Normal quicksort time complexity, no one will ask. What is the reason? Everyone knows. Normal quicksort algorithm time complexity, everyone. What is the time complexity? Best case, average case, n log n, worst case, n square. You know very well. But he will ask questions like that. What will be the worst case time complexity of quicksort if you take n by 5th smallest element as a pivot? N by 5th largest element as a pivot. N by 5th element as a pivot. He will ask something like that. Right? So, it is better to say few problems like that. I given this problem. Right? Please be careful. Now, before going to that, just I want to explain one small thing. Let me explain that also. Right? See this one. Carefully listen. I am explaining. See everyone. 50, 50, 70, 20. Next one is going to be 60, 40, 10, 30, 'Next one is going to be, I think, let me give some more number. Total how many elements are there? 7 elements are there. It's okay. Fine. Fine. So this is the array. See this one. 1, 2, 3, 4, 5, 6, 7. 7 elements are there. So this is the array. Please carefully listen. One point I want to say. This is the array. Can you help me now? In this array, please listen. In this array, if you take the right normal quicksort means what? First element as a pivot. If you take the first element as a pivot, see this one. If you take first element as a pivot and if you apply partition algorithm, what will happen? You know very well. Roughly I am writing. I am applying partition algorithm, but partition algorithm logic I am following. You know very well. Normal partition algorithm you know very well. In examination, anywhere any question is given, partition algorithm, whatever you know, P, Q, Ij, like that you do. Just I am giving roughly here. Roughly I am giving. Please be careful. On this array, if you take 50 as the pivot, if you apply partition algorithm, roughly see the answer. Roughly what the answer for this one? 50 will go to correct place, less than 50 one side, more than 50 other side. Can you read once? Can you read once? Who is the less than 50? Just do one scan. Less than 50. Who are those? 20. Just whatever order they are coming, just write. I'm doing roughly, please be careful. If someone asks you partition algorithm, do like in the right before this whatever we done. Before this, whatever we done, like that you do. P, Q, I, J, like that you do, right? Just I am giving roughly. Can you help me now? If you take 50 as the pivot, if you apply partition algorithm, 50 will go to correct place, less than 50 one side, more than 50 other side. Who is the less than 50? 20, next. Next one is going to be 40. Next one is going to be 10. Next one is going to be 30. It is the less than 50. Can you see who is the more than 50? More than 50 is going to be 70 and 60, right? Like that. That elements 1, 2, 3, 4, 5, 6, 7, roughly I written. Just my goal is you everyone know. If you apply on this array by taking 50 as the pivot element partition algorithm, 50 will go to correct place. Less than 50 one side, more than 50 other side. This order I am not taking that much care. My only goal is, right, partition algorithm logic I written. 50 as the pivot, 50 will go to correct place. Less than 50 one side, more than 50 other side. Less than 50, I didn't bother that much about the order. Roughly I written. More than 50, right? Roughly I written. Now, partition algorithm if you apply by taking 50, this is the approximate answer. Now, let me ask you one small line. Not only partition algorithm will do like that, you will return the position where pivot element went also. Which place pivot element went? 5th place. It will return 5. On this array, if you take 50 as the pivot, if you apply the partition algorithm, 50 will go to correct place, less than 50 one side, more than 50 other side, like that. Finally, it will not only do like that, it will return the pivot element which place it went, which place it went, 5th place, it will return 5. Now, if you are really comfortable with this, let me give one more example. Roughly I written, please be careful, roughly. Partition algorithm if you apply on this, right, answer may change slightly in this area. But one thing, 50 will go to correct place, you know this very well, right? Fine, roughly same answer. Next one, let's see one more line. Make sure that you listen this also. See this one, 20, 70, 10, 60, 40, 30, 'So I think totally 7 elements are there. It's okay. 1, 2, 3, 4, 5, 6, 7. Now let me apply a partition algorithm by taking first element as a pivot. Let me apply. 20 will go to correct place, less than 20 one side, more than 20 other side. Who is the less than 20? Just do one scan and check 10. Who is the more than 20? Don't bother about the order, just whatever order they are coming, just write. Right? You know partition algorithm very well. Right? Just I am giving roughly. Who is the more than 20? 70, 60, 40, 30, 50, 1, 2, 3, 4, 5, 6, 7, which will goes to, what is the answer? I think it will goes to 2. Right, that is also okay. I am thinking you are really comfortable, right? Let me ask you. These two examples are enough. Listen, to solve this problem, this example required. That is the reason I am explaining. Right? These two, partition algorithm behavior I want to explain. Even though you know partition algorithm behavior, one new point is there to explain that I am doing this story. Right? So I think two examples I given. See this one, example 1, to solve our problem. Two examples I given. It is example 1, it is example 2. Right? Now let me explain. What happened exactly? Let me explain. Carefully listen. Carefully listen. Can you help me one small line? Listen, interesting answer. Carefully listen one small line. In this array, you only say, in this array, who is the first smallest element in this array? In this array, who is the first smallest element? 10. Second smallest element, 20. Third smallest element, 30. Fourth smallest element, 40. Fifth smallest element, right? 50. Right? Can you help in this array, first smallest element 10, second smallest element 20, third smallest element 30, fourth smallest element is 40. Carefully listen. Fifth smallest element is 50. Listen now. Fifth smallest element is 50. Carefully listen. So 50 is a fifth smallest element. Now can you help me now? 50 is a fifth smallest element, it's okay. Can you help me in this array, which element you taken as a pivot? In this array, you are taken 50, first element as a pivot you are taken. In this array, if you take 50 as the pivot, which is the first element, which is nothing but fifth smallest element. Carefully listen. If you take first element as a pivot, which is the fifth smallest element, after partition algorithm is over, it will go to 5th place. Please be careful. In the given array, if you take the fifth smallest element as a pivot, after partition algorithm is over, it will go to fifth place. Please be careful. And once again I am repeating now. In the partition algorithm, if you take first element as the pivot, after partition algorithm is over, he can go anywhere. In the given array, if you take first element as the pivot, after partition algorithm, he can go anywhere. But if you take fifth smallest element as a pivot, he will go to fifth place. First element can go anywhere, but fifth smallest element will go to fifth place. Please be careful. Can you help me now? In the given array, if you take middle element as the pivot, where he can go? Middle element can go anywhere after partition. Because I don't know anything about middle element. Middle element, how it look like also I don't know. If I take last element as a pivot, where it can go? Anywhere. If I take first element as a pivot, where it can go? Anywhere. If you want, you can check. First element went to the fifth place. First element went to the second place. So if you take first element as a pivot, it can go anywhere. But one thing, if you take fifth smallest element as a pivot, after partition algorithm, it will go to fifth place. If you take, interesting answer, see in this array also, in this array, who is the first minimum? 10. Who is the second minimum? 20. See this one. In this array, first minimum 10, second minimum 20. See this one. If you take second minimum as a pivot, after partition algorithm is over, it will go to second place. Please be careful. Second minimum as a pivot, if you take after partition algorithm is over, it will go to second place. If you take the fifth minimum as pivot after partition algorithm, it will go to fifth place. I am thinking you are absolutely fine. Now listen, from this one, conclusion. In the given array, if you take the 10th element as the pivot, where it can go? Anywhere. 10th element I don't know anything about. 10th place anyone can be there. 10th element can go anywhere if you take pivot. First element if you take pivot, anywhere it can go. Last element if you take pivot element, anywhere it can go. If you take middle element as the pivot, it can go anywhere. But one thing I can say, right? If you take the fifth smallest element as the pivot, not fifth element, fifth smallest element as the pivot, it will go to fifth place after partition. If you take 10th smallest element as a pivot after partition algorithm is over, it will go to 10th place. Please be careful if you really comfortable with these lines, right? Now read our problem. Read the problem. Our problem, read. See this. Now you are easily give the answer. Check. In quicksort, the sorting of n numbers, the n by fifth smallest element is selected as a pivot using order of n time complexity algorithm. Then what will be the worst case time complexity of quicksort? The n by fifth smallest element is selected as a pivot using order of n time complexity algorithm. Then what will be the worst case time complexity of quicksort? Can you say which element you selected as a pivot? N by fifth smallest element is selected as a pivot. Now I am giving the answer. See this one? I am giving the answer. Carefully listen. This is the problem. I am writing the answer above. Right? So problem is everything clear. See this one. N by fifth smallest element is selected as a pivot. See everyone, see roughly now, it is the array. Everyone listen, it is the array. Roughly, it is the array. Can you help me now? In this array, which element is taking pivot? N by fifth smallest element is taking as pivot. In this array, n by fifth smallest element is taking as pivot. If you are comfortable, now see what the answer. See the answer. See the answer, interesting answer. Time complexity of the quicksort Tn is equal to, see everyone, time complexity of the quicksort Tn is equal to, if you want to apply time complex, if you want to find out time complexity of the quicksort, right, Tn is equal to, can you help me know, what is the first step of the quicksort? If you want to apply quicksort, you have to apply partition first. If you want to apply partition, you have to take pivot. Can you help me now? Normally, which element you will take pivot? First element. How much time? Constant. But now, which element you are taking pivot? N by fifth smallest element. How much time? Right? Order of n. See this one. Order of n time for pivot selection. If you want to do quicksort, you have to apply partition. If you want to apply partition, first you have to select pivot. So, order of n time pivot selection. Pivot or pivot? Pivot selection. Because pivot element is going to be n by fifth smallest element. Right, which will take order of n time. Now after selecting the pivot element, what is the next one? Right, partition algorithm. Partition algorithm normally one loop, one for loop. Right, this is for partition algorithm. This is a partition algorithm time complex. Pivot selection is order of n, after pivot selection, partition algorithm, one loop there, order of n, that is also okay. Now can you help me now? After partition algorithm is over, which element you taken as a pivot element? N by 5th smallest element. After partition algorithm is over, pivot element will go to n by 5th place. This is the place, right? N by 5th place, pivot element is there. Here pivot element is there. Right? Please be careful. Right? N by 5th element, right? N by 5th place, pivot element will go. Can you help me now? If the pivot element will go to n by 5th place, left how many people? Can you help me now? Here to here n by 5. Here n by 5 minus 1. Here how many? See this one. Here to here n by 5 remaining. What is the answer? N minus n by 5. N by 5th smallest element you selected as a pivot by taking order of n time. Afterwards you applied the partition algorithm. It will go to n by 5 place. Left hand side is, I think, here to here is n by 5. Left is going to be n by 5 minus 1. 1 less. Because including this one n by 5. Right? If you remove this one, n by 5. Next one, from here to here is n by 5. Remaining is n minus n by 5. Let me write now. Can you help me know what is the left side? Left side is t of n by 5 minus 1. What is the right side? T of n minus n by 5. Right? Like this. Now let me simplify further. Let me simplify further. Right? This one if you simplify, n plus n. What is the answer? 2n. If you want, you can write. Next one, t n by 5 minus 1. Forget about minus 1 plus 1. N by 5 plus t 4n by 5. Right? 4n by 5. I think 2 constant, you no need to think that much. Right? N plus t n by 5. T 4n by 5. Right? This one you solve using, right, recursive tree method. If you solve recursive tree method, what is the answer? First level answer is n. Second level, if you add both of them, then what is the answer? Right? One more n will come. See, n by 5 plus 4n by 5. Right? First level is n. Right? Second level, if you see, what is the answer? N by 5, right? 4n by 5. If you add them, one more n will come. Right? I think every level is n. How many level? If you always divide by 5, log n base 5. It is a log n base 5 by 4. Upper bound is going to be log n base 5 by 4. So what is the answer? Theta of n log n is the answer. If you want, you can write base also. 5 by 4. 5 by 4 is actually upper bound. Right? Next one, lower bound is base 5. Both differ by only constant only. Theta also you can write. The answer of this problem is going to be n log n base 5 by 4 or simply n log n. Because in gate examination, if you see the option, in the option there is no 5 by 4. Simply theta of n log n is there. Right? Theta means big O also there, omega also there. You know very well. And one more, can you help me one small line now? N by 5th smallest element if you take, n by 5th smallest element if you take, right? Where it will go? N by 5th place. If it will go n by 5th place, left how many? N by 5 minus 1. Right how many? Remaining, right? N minus n by 5, which will goes to 4n by 5. Some people are asking, sorry, it is actually 2n. How can you write the n? Suppose that here 2n only there, assume 2n only there. If 2n is there, what will happen is, right, when you solve this problem using recursive tree method, if at all here 2n is there, first level 2n, next level also 2n will come, next level also 2n. Like that how many time? Log n time. Every time 2n, log n time, 2n log n will come, where 2 is a constant. That is the reason I neglected the 2. If you want, you can keep 2 also. In the place of n log n, 2n log n will come, which will nothing but n log n only. So the answer of this problem is going to be, right, n log n. And one more thing, is it the best case or worst case? Is he asking best case or worst case in this problem? In this problem, is he asking best case or worst case? Worst case. Can you help me one small line now? He is asking worst case, it's okay, right? But one thing I want to ask you, if you take n by 5th smallest element, right, where it will go? N by 5th place. Can you help me now? If I take n by 5th smallest element, right, if at all it will go anywhere, it can go anywhere, then many answers will come. N by 5th smallest element I am taken. If at all it can go anywhere means what? Extreme corners also it can go, middle also it can go. Many possibilities are there, many answers there. Here only one possibility. N by 5th smallest element will go to n by 5th place only. Means only one division, perfect. N by 5th place he will go. More than, see, more divisions, more answers, one division only. N by 5th only it will go. Right? N by 5th only it will go means, I think this division only there. If this division only there, this answer only there. Can you say it's the best case or worst case or every case? Every case. Not only worst case, every case, because one division, one answer. Can you say why Quicksort normally having multiple answers? Best case is n log n, average case n log n, worst case n square. Why? Different divisions.
Why different division? If you take first element as a pivot, he can go anywhere. When you say anywhere, multiple answers will come. But now it is not anywhere. N by fifth smallest element will go to n by fifth place. Right? Please be careful. Right? That is the reason here only one answer. Even though you will say best case to this problem, n log n only. Even though you will say worst case, same answer. And one more, some students are asking me, right, sir, time complexity of the quicksand, normally you will take partition time plus this. Why are you taken? He mentioned in the problem. He mentioned in the problem, that is the reason I am taken. If you don't mention, I don't take. Normally partition algorithm time complex, see this one. Normally pivot selection constant. Normally pivot purpose I don't take the time. Because normally pivot selection constant. Because if in this problem is mentioned, I am taken. If you don't mention, I don't take. Specially is mentioned, right? I am taking pivot element, right? By taking order of n time. That is the reason this story came. Fine. Check properly. I am thinking that clearly I explained to you. To understand this problem, few basics required. I done this. These are the basics. If you take second smallest element as a pivot, it will go to second place. If you take the fifth smallest element as a pivot, it will go to fifth place. If you are okay with that, he is taking n by fifth smallest element as a pivot, it will go to n by fifth place. If it will go to n by fifth place, left n by 5 minus 1, right 4n by 5. If you simplify this one, right, n plus tn by 5 plus 4n by 5. Using recursive tree method, this is the answer. Forget about the base, n log n. Which case? Every case. Why? Only one division, only one answer. Even though you will say average case, same answer. Worst case, same answer. Best case, same answer. Right? Fine. I am thinking you are absolutely fine. See the next problem. It is a nice one. Please read this. If you really understood the previous problem, mostly you will give answer for this problem. If you understand the previous problem, definitely you will give answer for this. Right? Please check once. In quicksort, the sorting of n numbers, the n by 50 element is selected as a pivot using order of n square time complexity algorithm. Then what will be the worst case time complexity of quicksort? Right? So same thing like previous, but what is the difference? Pivot selection how much time? N square. What he done also we don't know. We really not interested. See this one. If anyone thinking about how he done and all, right? You are not thinking about the quicksort. You are thinking about something else. Please be careful. Right? I am repeating once again now. Pivot selection is order of n square. How? Is given. Why you think? Why you think unnecessarily? Right? Please be careful. Pivot selection is order of n square. Which element is selected as a pivot? N by fifth element. N by fifth element selected as a pivot element using order of n square time complexity algorithm. Then what will be the worst case time complexity of quicksort? See, worst case is asking. Right? Then what will be the worst case time complexity is asking. Right. Now see this. Now I will give the answer. Please see. So I am starting. Everything is ready. I am starting now. Please listen. Please listen. See this one I am writing now. Very simple answer. Time complexity of the quicksort Tn is equal to. Time complexity of the quicksort Tn is equal to. Can you help me? What is the first step? Pivot selection. How much? Order of n square. Pivot selection. I am writing also. Pivot selection. Next one, order of n square for pivot selection, it's okay. Next one, afterwards partition algorithm. Partition algorithm is as usual. Order of n time for partition algorithm because one loop. Partition algorithm. Okay, partition algorithm. Roughly I written. Next one. So pivot selection is order of n square. Partition algorithm is order of n. Next one. Can you help me one small line now? Which element you selected as a pivot? N by 50 element. Please be careful. N by 50 element. Like first element, like second element, like third element, n by fifth element. Can you help me? If you take first element as a pivot, where you can go? Anywhere. If you take 10th element as a pivot, where you can go? Anywhere. 10th element can go anywhere. N by fifth element also can go anywhere. When you say anywhere, many answers will come. Can you help me now? When you say anywhere, many answers will come. Can you help me now? If you are lucky, what will happen? Because of n by fifth element, if you are lucky, you can go to mid. Maybe best case will come. Right? If you are unlucky, where you can go? You may go to extreme corners either here or here, right? Like this. So because of n by fifth element you taken, it can go anywhere. So I think two different answers will come, worst case or best case. Because of he is saying worst case, right? Worst behavior will happen. Then what is the answer? This may be the case. T of 0, T of n minus 1. Because of he is saying he want worst behavior. Anywhere it can go. So I have two options. Either best or worst, I am unable to decide. He is saying worst case. Then go for worst behavior. Right? N by fifth element can go anywhere because like first element, like second element, n by fifth element. So this is. Now if you simplify now, what is the answer? Order of n square n becomes n square. Next one, t of 0 is, just leave it, t of n minus 1. Right? If you solve this one, what is the answer? I think it will become like this one, 1 square, 2 square, 3 square, and so on, n square. Right? Which will goes to sum of, right, n natural number square. What is the answer? N into n plus 1, 2n plus 1, right, by 6. Right? Which will goes to big O of n cube. Which will goes to big O of n cube. But I'm thinking you are comfortable. To this problem, because of worst case, answer became n cube. Some students are asking, sir, quicksort algorithm worst case is order of n square. How you got n cube, right? That is a normal quicksort worst case is n square, right? But this quicksort, right, some change there. What is the change? Normally quicksort is first element is a pivot constant, but pivot selection here itself n square. That is the reason. So try to remember, those people who will by heart, they will give answer for this problem is n square only. Right? Small change there, automatically answer will change. Right? If nothing mentioned, quicksort worst case n square, quicksort best case, right, n log n, quicksort average case n log n. If something extra added, something extra will come. Right? Please be careful. To this problem, worst case is this much. Suppose in that he mentioned best case, best partition will happen Tn by 2, which will become n square plus 2Tn by 2. Which will become n square, right? I solved many times, n square. Because of worst case, n cube, because if at all best case, n square will come, right? To this problem, this is the answer. Please take care, previous problem, this problem same, but previous problem, n by fifth, smallest element 2, but it is n by fifth element, right? This is the answer. Yeah, let's see another problem of quicksort, which is given in one of the previous paper. See this? In quicksort, the sorting of n numbers, 28th largest element is selected as a pivot using order of log n time. How they done? Really, I don't know. 28th largest element using order of log n time. How they done? This is not my goal. That is the reason I am not thinking. Right? Something they written. I have to use it. Right? If they ask me how you are finding, right? How you are finding the 28th largest element order of log n? If that is the question, I will think about. It's something else. Here the question is belongs to quicksort. Think about quicksort only. In quicksort, the sorting of n numbers, 28th largest element is selected as a pivot using order of log n time complexity algorithm. Then what will be the best case time complexity of quicksort? Right? Now let me ask you one small line. Please listen. Now. Listen everyone. One interesting point I want to say to you. Just listen. Right? Listen everyone now. If I take first element as a pivot, where I will go? If I take first element as a pivot in the quicksort, where I will go? Anywhere. That's okay. If I take first smallest element as a pivot, try to remember, if I take first smallest element as a pivot, I will go to first place. That's okay. If I take 10th smallest element as a pivot, I will go to 10th place. That is also okay. Right? If I take the n by 5th smallest element as a pivot, I will go to n by 5th place. That is also okay. Now you only say, if I take n by 5th smallest element, I will go to n by 5th place. It's okay. If I take nth smallest element as the pivot, I will go to nth place. If I take nth smallest element as a pivot, I will go to nth place. Nth place means what? Last place. Means from the last to first place. Please be careful. If I take nth smallest element as a pivot, I will go to nth place. Means from the last to first place. Try to remember. Nth smallest element is nothing but largest element. First smallest element is small. Nth smallest means large. What is the meaning? If you take nth smallest element as a pivot, you will go to nth place. Means you will go to first place from the last. Another way of saying, if you take first largest element as a pivot, you will go to first place from the last. Again I am asking you, if I take n minus 1 smallest element as a pivot, I will go to n minus 1. I will go to n minus 1 place from the first to n minus 1. From the last to second place. n minus 1 smallest means what? Second largest. What is the meaning of nth smallest element? First large. n minus 1 smallest element, second large. n minus 2 largest element, third, right? N minus 1 smallest element, third large, something like that. Now if those people who are really understand whatever I said until now, final conclusion, can you help, where first largest element will go if you take as pivot? First place from the last. Where second largest will go if you take as pivot? Second place from the last. Where the 10th largest element will go if you take as a pivot, right? 10th place from the last. Please be careful, right? 10th place from the last. I'm thinking that you are okay. If you are okay, now read this problem. In quicksort, the sorting of n numbers, 28th largest element is selected as a pivot using order of log n time complexity algorithm. Then what will be the, so I'm starting now. What is the answer for this? Please see this. See the answer. This is the array. This is the array. So if you take 28th largest element as a pivot, right? So using order of log n time complexity, what is the time complexity asking? Can you help, So what will happen? It will go to 28th place from the last. Please be careful. Now see the answer. I'm starting. Time complexity of quicksort algorithm Tn is equal to, right? First, what is the answer? Order of log n, pivot selection. Next one, order of n, partition algorithm. Right? Plus. Now can you help, So by taking 28th largest element as a pivot, if you apply partition algorithm, where it will go? From the last to 28th place, means from here 28th place. From here means, what is the meaning? From here to here 28 means how many here, right? 28 minus 1. From here to here 28 means, I think if you accept this one, 28 minus 1. Can you say from this side? Remaining all, what is the meaning? N minus 28, right? So what is the left? Left contain how many? T of n minus 28. What is the right? T of 27, right? Let me simplify further. Because of lack of space I written, right? It is not some design and all. Some people are thinking that some design happened. No, right? Lack of space I done, right? Please be careful. Next one, log n plus n. What is the answer? Log n plus n. What is the answer? N plus T of n minus 28, T of 27. Everyone know the constant elements will take constant time. Don't think that much. This one think about T of n minus 28. Now this one you know very well. What is the answer? I think every time if you subtract to n by 2 levels, if you subtract every time n by 28, n by 28 levels will come. Always you are subtracting to n by 2. Always you are subtracting 5, right? N by 5 will come. Always subtracting 28, n by 28 levels will come. N by 28 levels will come everywhere approximately n like that, right? N by 28 times approximately. So final answer is going to be, what is the answer? N by 28 into, right, n. Final answer is big O of n square. If you want, you can right, try this also, right? Indirectly, directly same story. Every time you are subtracting 28, n by 28 levels will come. Everywhere approximately n like that. So n by 28 times n. So n by 28 into n, big O of n square. It is something like constant element one side, remaining other side, something like that, right? So he is asking best case or worst case? Best case. See the interesting answer. He is not asking worst case. He is asking best case. Can you help, to this problem? Best case answer what? What is the best case time complexity of this problem? Can you help me one small line now? Best case or worst case, forget about. Which element you taken as a pivot element? 28th largest element, where it will go? 28th largest element will go from the last to 28. 28th largest element will go from the last to 28. Means what is the meaning? This is the only division possible. From the last to 28 place it will go. Best case also same place it will go. Worst case also same place it will go. When I have a choice, then different answers will come. I don't have any choice here. 28th largest element, I will go to 28th place. That's it. 28th largest element, I will go to 28th place. Right? So please be careful. That is the reason. Best case also same answer, worst case also same answer, because only one division possible. Only one division, one answer is possible. But I'm thinking that you are really comfortable, right? This problem, previous problem same. Previous one is going to be, right, something like n by 50 element. Before n by 50 smallest element. This is 28th largest element. Right? Small changes. So let's see the last problem of quicksort. See this. Last problem of quicksort. In quicksort, the sorting of n numbers, the n by fifth smallest element is selected as the pivot using order of n square time complexity algorithm, then what will be the best case time complexity of quicksort? Easily you can handle. Only for your practice purpose I given this problem. Let's start. So in this problem, which element you are taken as a pivot? N by fifth smallest element. Let me round it. N by fifth smallest element, if you take pivot element, where it will go? N by fifth place. N by fifth place or anywhere? N by fifth place always. Right? Next one, pivot selection, how much time? Order of n square. Next one, which case he is asking? Best case. Everything is fine. Now I am starting. See the answer. Time complexity of the quicksort Tn is equal to. Time complexity of the quicksort Tn is equal to. See the answer. Partition algorithm. Sorry. Pivot selection n square. Partition algorithm n. Pivot selection is n square. Partition algorithm is n. Next one. How you divided? N by fifth smallest element you selected. It will go to n by fifth place anyhow. Left how many? T of n by 5 minus 1. Right how many? T of. Right? I think 1 to n by 5. Remaining is n minus n by 5. So which will goes to? Which will goes to what the answer? I think it will goes to n square plus t n by 5 roughly t, right, 4n by 5. Right? So this one if you solve, first level cost is n square. Second one is going to be, if you want you can check, n there n square. Second one, n by 5 there, n by 5 whole square. 4n by 5 there, 4n by 5 whole square. So finally below 25 will come, above I think 17 will come, 17 n square. Let's see this one, it is like this one, n square. Next one is going to be 17 by 25 whole power 1 n square. Next one 17 by 25. If you want you can verify, many times I done. Right? So this one n square. So it will continue like this one. How many times? Upper bound. Right? Upper bound 17 by 25 whole power. What is the answer? 1 is log n base 5, 1 is log n base 5 by 4. Upper bound I want log n base 5 by 4 n square. If you common the n square, what is the answer? It is decreasing GP series. So n square into decreasing GP series constant. Finally big O of n square. Big O of n square. Right? You know very well how to do recursive tree method. You know very well, because if I done many time directly I return. This is going to be what the answer? 17 by 25 whole power 0. Right? First level, second level differ means series coming. Right? Which series? I think R value less than 1. Right? Decreasing GP series. 17 by 25 means what? Less than 1. Right? So answer is finally n square. Which case? Every case, because n by fifth smallest element will go to n by, right, n by fifth place every time. Every time means every time same answer. To this problem always n square will come. Now let's see the some small conclusions. See the small conclusion. Listen now. Listen. In one of the previous paper, one question is given saying that what is the time complexity of the quicksort algorithm if you take middle element as the pivot? If you take middle element as the pivot. If you take middle element as a pivot, worst case time complexity of the quicksort, how much? What is the answer? If you take middle element as a pivot, like first element, second element, middle element means what? N by 2 element, middle element I am writing now. Middle element means n by 2 element. N by 2 element, please be careful. Time complexity of quicksort worst case, if you take middle element as the pivot, means n by 2 element as the pivot. What is the answer? Big O of n square. Because it can go anywhere, worst thing can happen. That is the meaning of middle element. Middle element means n by 2 element. Now see the one more interesting answer. What is the time complexity of quicksort algorithm? If you take, see this one. If you take median as pivot. If you take median as pivot, median means, I am giving the answer. Median means, try to remember, n by 2 smallest element. Try to remember, middle element means n by 2 element. Median means, right, n by 2 smallest element. What is the worst case they are asking? If you take n by 2 smallest element, it will go to n by 2 place. Means 50-50. So finally n log n will come. Please check. If you take median as a pivot element, which is the n by 2 smallest element, right, time complexity is going to be worst case, every case n log n, because it will divide exactly 2 parts. Middle element is different, median is different. Middle element is n by 2 element, median is n by 2 smallest element. Right? So here, right, worst case is n square, but best case is n log n. Because anyway, it can divide many ways, but it can divide one way only. So one answer. Worst case, best case, average case, same. But here, worst case only this one. Best case, n log n. Best case and average case, right? Fine. Now you are okay. Just I want to differentiate what is the middle element, what is the median, right? This is the difference. Middle element means n by 2 element, median means n by 2 smallest element. And one more, one note I am writing, this one note I am writing. In unsorted array, note, I am writing note also. In unsorted array of n element, not sorted array, unsorted array of n elements. In unsorted array of n elements, to find median, time complexity, big O of n, right? Every case there is a one best algorithm there, right? Please take care. It is a note. Remember this. In unsorted array of n elements, to find median, time complexity is order of n every case, right? So some people are asking, sir, how? Right? Please find out yourself, right? I want to cover all, but right, it will take lot of time. Right? This is not that much important, but this statement is important. Proof is not important. This statement is important. Please be careful. How to find out this one? Google it out. In the YouTube you search. In the Coreman you search. You do whatever way you want. This is the note which you have to remember. In unsorted array of n elements, to find median, time complexity order of n every case. Median will be computed with order of n time every case. It is a note. Please be careful. Because of your median, just I want to say this also. Other than this, nothing there. Right? Median, if you take pivot, time complexity of quicksort is every case n log n. Some people are asking, sir, median computing itself may be taking more time. Right? In unsorted array of n elements, to find median, time complexity order of n every case. It is a well-known algorithm, right? Well-known algorithm. Please go through it. Proof I want to give, but it will take some time. Fine, that is enough. Now let's go to the next one. See the next one. In the quicksort, everything I completed. This is the small thing pending. Let's do this also. Otherwise, you may think that it is a complex one. That is the reason I am covering. Randomized quicksort. In the quicksort, everything I done. This is only small part which is left out. It is really not required, but only for namesake I am explaining. Can you help me know what the meaning of randomized quicksort? Let me explain now. Listen. Whenever quicksort is going on, you only say quicksort is a recursive algorithm or non-recursive algorithm. Recursive algorithm, right? Quicksort is a recursive algorithm. Whenever quicksort algorithm, recursive algorithm is going on, right? If you can write equivalent to non-recursion also, internally while loop is there. Other than this, nothing there. Quicksort recursive algorithm means doing the same work again and again. Right? If you write the using non-recursion, some while loop is there. There also you are doing the same work again and again. Now listen, whenever quicksort is going on, because of the recursion, right? It is keep on calling same thing again and again. What is the meaning? Internally partition there, that also running again and again. Quicksort is running means partition algorithm is running again and again. You know this very well. Can you help me now? Quicksort is running internally, partition also running. How many times? Because of recursion. Many times partition algorithm is running inside. Whenever partition algorithm is running many times, right? Assume that partition algorithm is running first time. Assume quicksort is running, automatically partition will run. Partition will run many times. You know, assume that partition is running many times. Whenever partition algorithm is running first time, it has to select some pivot. Normally, which one you select? First element. So first time partition is started, right? First element I selected as a pivot. Whenever second time partition algorithm is started, again first one I will select. In the available element, first element. Whenever third time partition algorithm is going on, again first element I will select. What is the meaning? Whenever quicksort is going on, partition algorithm is many times. So every time I will select. Every time I will select first element as the pivot. Then it is called quicksort. If you select every time last element as the pivot, that is also quicksort. If you select every time middle element as the pivot, that is also quicksort. If you select pivot always from same place, that may be always first two, that may be always last two, that may be always middle. Whenever quicksort is going on, partition algorithm is many time, right? Whenever partition algorithm is going on, every time from same place you are selecting the pivot, then it is known as quicksort. Suppose assume that partition algorithm is running many times. First time pivot element you selected the first element, second time you selected the pivot element middle element, third time you selected the pivot element last element. What is the meaning? Pivot selection is keep on changing. That is called randomized quicksort. If anyone asks you what is the meaning of randomized quicksort, what will you say? When quicksort algorithm is going on, pivot selection is keep on changing. Means recursion means same code is running again and again, but every time different pivot element you are taking. Sometime first one, sometime second one, sometime third one, something like that. Right? This is called as a randomized quicksort. This is called a randomized quicksort. Right? Please be careful. It is something like this one. It is something like this one. See, whenever your college is going on, assume that your college is morning 9 o'clock. Your college is morning 9 o'clock. Some people what they will do is every day, 9 o'clock college, right? Every day, exactly 9 o'clock they will go to college. Every day they will go exactly 9, right? 9 o'clock college, every day exactly 9 they will go. This is called normal quicksort. Every day same. What some nonsense people will do is one day 8 o'clock, one day 7 o'clock, one day 9 o'clock, one day 10 o'clock, one day 11 o'clock. Randomly they will go. Randomly, right? This is called as randomized quicksort. Randomly if you visit, right, then at that time you are not a student, you are a visiting professor. When you are a student, you should have the, right, you should have I think discipline, something like that. Exactly 9, I see many students, exactly 9 they will come. 9 o'clock class, exactly 9 they will come. Right? Some bullshit people are there. What they will do is 9 o'clock class, they are visiting professor, 10 o'clock they will come. 11 o'clock they will come. 7 o'clock. I asked one student, how can you come like this? He simply said that, just I am applying a randomized quicksort, something like that. I also laughed, he also laughed, something like that. But one thing, randomized quicksort means selecting pivot element randomly, nothing there. Right? Fine. So let me write now, randomized quicksort. Selecting pivot element randomly. Selecting pivot element randomly is known as randomized quicksort. Next one, 2, second one. I am writing that line as this one. Randomization will improve the performance. That is the reason they are doing. Randomization will improve the performance. So see this one, older days in the software industry, if you observe older days, right, exact time you have to go, right, correct time you should go, correct time you should come, correct time you should go, something like that, right, in the older days, right, nowadays, right, software industry is a little bit changed, right, what they are saying is, you come whenever you want, just complete the task and you go, something like randomization, you come anytime. You want to come, so because that company want to keep some restrictions also, come 9, go 6 o'clock. They kept, but many people are not happy because of those rules and all, right? That is the reason. So companies, what they decided is, at the end of the day, they want work and all. They simply said that come anytime and go anytime. We don't have any objection, right? The only thing is we want result, right? So if you do flexibility, performance may improve. That may be the case. Some students are asking, sir, why can't, right? Same rules will be applicable for students also. They will also come whenever they want, they will also go whenever they want. Just I want to say shut up. Other than this, nothing there. Right? I want to say shut up, shut your mouth. Students we cannot, they don't give, because students says is the correct time, right? Having discipline and all. That may be the reason. Otherwise they could, right? Otherwise they could have kept, right? At the student also same story. That is a place where, right, you have to follow some discipline and all. Anyhow, after coming to the industry, you will also, right, come whenever you want, you will also go whenever you want, right? As a student, let's have discipline, right? This is the only place where all the nice things will be learned. Afterwards, after going to the industry, right, I think they will give a lot of flexibility. When you have nice discipline, automatically you will get the nice company and all, something like that. Anyhow, see these 2 lines. First line, selecting pivot element randomly is known as randomized quicksort. Second one, randomization will improve the performance. Right? These are the 2 reasons why, right, the concept of randomized quicksort is came. So let's go for one example. Let's go for randomized quicksort, right? Let's go for one example.
See the example now. See the example. 10, 20, 30, 40, 50, 60, 70. 1, 2, 3, 4, 5, 6, 7. Now can you help me now? Right, this is the array. Carefully listen. This is the array. Right, this is the array. So can you help me now? This is the array. It's okay, fine. Is it sorted array or unsorted array? See, it is sorted array. Can you help me on this sorted array? If you apply the quicksort algorithm, you know, right? Right before this I explained also. On the sorted array, if you apply the quicksort algorithm, because of the ascending order, always you will take first element as a pivot, which is the smaller one, means left no one will come, left gap will come. On this array, if you apply the quicksort algorithm, always you will take first element as a pivot, left gap will come. Everyone know. Always left gap will come. We done this problem already. Right? But see this one, if you take always first element as a pivot, left always gap is coming, it is going to be unbalanced tree will come, right? N level tree will come. Every level partition algorithm n level, n square. You know very well. To this particular input, quicksort algorithm will give order of n square return. Please be careful. Right? I will write here. See this one. To this one, what is the answer? N level tree will come, unbalanced tree. Right? N level tree will come. So, n level tree everywhere n, order of n square. Right? You know this very well. About normal quicksort I am talking. For this input, if you apply normal quicksort, right, n level tree will come because unbalanced behavior, left gap. This kind of diagram will come. N elements, right? Partition algorithm is over 0 elements here, n minus 1. Same thing will happen, 0, n minus 2. So, everywhere approximately n time. Right? So, like that n times will happen. N times n square, right? Like that you know very well, right? Before this we are already covered. Now let's see the interesting answer. If you take always first element as a pivot, that is the problem, right? What is the random algebraic quicksort will do? See this one. Random generator function you will call. Random algebraic quicksort first step is going to be, right? See this one. Random generator function you will call. See this one. Array A which contain 1 to 7, random generator function you will call. Assume that when you call, right, he returns some number 1 to 7 elements. Which element I have to take pivot? I will ask the random generator function. He return randomly one number. Assume that he return randomly one number R. That may be anything. Assume that R may be 4. He return 4. I asked the random generator function. I want to apply quicksort algorithm. Means I want to apply partition. Means I need pivot element. Please give one pivot element in 1 to 7. Random generator function randomly generated one number, that is R, that is 4. Right? Fine. Now see this one. So what the random generator function saying? Take 4th element as the pivot. That's what the random generator function is saying. Now see the second step what he will do. Swap. Because of he is saying take the 4th element as a pivot, but I know only one algorithm. What is that? Taking first element as a pivot. I know taking first element as a pivot, but he is saying take 4th element as a pivot. See what he will do. Swap. A of P means first element and A of R, right? Rth element. Swap both. Swap these two things. Swap these two things. If you swap, it will become 40. It will become 10. Swap both the things, it will become 40, it will become 10. Now after swapping, who is there in the first place? 40, whom you selected as a pivot. Now apply normal quicksort. Right, this one I want to take 4th element as a pivot, but I know first element as a pivot algorithm only. Swap them so that first place 4th element will be there. Now you apply partition algorithm, which is nothing but 4th element as a pivot, you are applying partition algorithm. Other than this, nothing. Apply now. Apply. So what will happen now? You know very well partition algorithm. What is the answer? P, Q, I, J. Like that you can apply. In exam you can follow like that. Let me give roughly answer. Can you say which element is a pivot? 40. If you take 40 as the pivot, less than 40 one side, more than 40 other side. Can you say what is the less than 40? Roughly you write less than 40. Whatever order they are coming, right? What is the answer? Less than 40, 20. I think 30 also. 10 also. Next one. Who is the more than 40? 50, 60, 70. Right? Like this. Right? Now can you help me once more? One small question I want to ask you. Given array is what? Given array is a sorted array. If the given array is a sorted array, if you apply the normal quicksort algorithm, every time left gap will come. Every time. Because first element you will take pivot. Less than that no one.
Always left gap will come. Can you say what is the meaning of worst case of quicksort? What is the meaning of worst case of quicksort? Whenever quicksort is going on, partition algorithm is many time, every time, right? One side gap is there. Every time worst thing happening. Majority times worst thing happening, then that is the reason worst case. What is the meaning of best case? Majority times best case came. Then best case. What is the meaning of average case? Half time best, half time worst. Half time best, half time worst. Right, which will leads to average case. What is the meaning of best case? Always best thing happening. Most of the time best thing, best case. Most of the time worst thing, then worst case. Half time best, half time worst, that is called worst case. To this input, if I apply normal quicksort algorithm, always worst happening because left gap. But if you want, you can observe. If you apply randomized quicksort algorithm, one round over, see best partition happened. This input, one best partition also not there, but in this one some best partitions are happened. See this one, if you take randomly pivot element, performance will improve. That is the reason randomized quicksort is there. That is the reason, otherwise why it is there? Selecting pivot element randomly is known as randomized quicksort. Why they are doing that? Performance is improving. Let me go to the next one. See the answer. 1 2 3 4 5 6 7. Now I think here also randomized quicksort I have to apply. Here also I have to apply randomized quicksort. I think same procedure. What is that one? Same. See this one. Randomized. See this one. Random generator of A. Random generator of 1 2 3. In the 1 2 3, which element I have to take pivot? I asked the random generator. He will return randomly some number. Isn't that 1? What is the meaning? He is saying take first element as a pivot. If you take first element as a pivot, what are the next steps? Swap. As usual, swap. A of P, A of R. Swap. Right, both. A of P and A of R. When you swap it, I think both are that itself. Now apply partition algorithm on this one. 20 will go to correct place, less than 20 one side, more than 20 other side. What is the less than 20? Scan once, 10. What is the more than 20? 30. I think again best came. Again best came because of one element stop. Let's come here again. See this one. R is equal to random generator of, what is the answer? 5 to 7. In 5 to 7, which element I have to take as pivot? I asked with the random generator function. He returned randomly one number. Isn't that he returned 7? Now same way, swap. A of P means first element. A of R, right? Swap them. This is 50. This is 70. 70 will come here, 50 will go here. Now apply partition algorithm. What is the answer? Who is the pivot? 70. Less than 70 one side, more than 70 another side. Who is the more than 70 here? No one. Who is the less than 70? 60, 50, see. Again worst partition. Right? Again let me write 5, 6, 7. Now in this, again random generator. Random generator of 5, 6. You will return some number R. Right? You will return some number R. Assume that R may be 6. Next one, swap. A of P, A of R. Right? Then swap them. This is 50. This is 60. After swapping, apply partition algorithm. What is the answer? 50 will go to correct place. Less than 50 once and more than 50, 60. One element there, stop. Now if you observe clearly, right? If you observe clearly, see this one. For this input, if you observe clearly, for this input, if you apply normal quicksort, always worst partition. See, always worst partition. But here if you observe, see this one. See, first time best partition. Second time also best partition. Third time worst partition. Next time best partition. If you see overall, what is that one? I think half time best partition, half time worst partition. It leads to, what is the final answer? Average case. Previously it is the worst case, now it became average case. Right? Answer is going to be n log n. That is the meaning of randomized quicksort will improve the performance. If I do on this every time same, right? That kind of behavior is coming n square. If I do randomization, performance is improving. Sometimes best, sometimes worst. Overall, if you observe, right? Approximately half time best, half time worst. It is a very rare incident, right? Every time worst partition will happen, right? So sometimes best, sometimes worst coming. Average is going to be n log n, right? Please be careful. So this input is actually previously worst case. Now average came, which is n log n. Now see the final conclusion. Quicksort algorithm. Quicksort algorithm can help in a quicksort algorithm time complexity. See, best case. Time complexity we are talking, right? Space you know very well. Quicksort algorithm, best case time complexity, what is the answer? N log n. Average case, what is the answer? N log n. That's okay. Can you say worst case? N square. Quicksort algorithm worst case is n square, that is fine. Can you say quicksort algorithm worst case n square, it is fine, but still quicksort is the best one. What is the reason? It is a very rare incident. Very rare incident. What is the meaning? Out of 100 inputs if you give, maybe I think 5 people will give worst case. That is also if array already sorted. If array already sorted, then only it will come like that. Right? Otherwise not. It's very rare incident, that is the reason. It is the most practically used sorting algorithm. Even the worst case n square is there only for exam purpose. Only for exam purpose it is there. Right? So only for exam. See, out of 100 inputs, only 10 people can give worst case. Remaining all will give best case or average case. But anyhow, right? Namesake quicksort worst case n square is there, but actually, right? Actually quicksort is n log n. So out of 100 people, very less people will give worst case. Assume that 10 out of 100, 10 people will give worst case. One also there, that is fine, right? So at least one also there which will give worst case. That may be the reason worst case n square. But see the one more interesting answer. If you apply randomized quicksort algorithm, see the best case n log n, average case n log n. See the answer. Best case is n log n, average case n log n. See the worst case is going to be n square. Randomized quicksort also will give worst case n square. Some people are asking, sir, how? Right? Whenever sees one, he is taking randomly. After taking randomly also, sometime, right, problem may come. Whenever that day is not your day, you do whatever way you want. Worst case may come. It is something like this one. Prime Minister, see this one. Prime Minister having lot of security. In entire India, Prime Minister having lot of security. Sometime, whenever God is not with them, even though lot of security there, no one can stop. Say Rajiv Gandhi, Indira Gandhi, you know very well. Lot of security there, but still someone is killed them. What I want to say is, it doesn't matter what you do, right? Worst case, 100% efficiency, you may not find out. Right? Same thing. Comparing the randomized quicksort and normal quicksort, randomized quicksort improved the performance. What is the meaning? Right? Best case both n log n, average case both n log n. Out of 100, right? Quicksort is giving for 10 people n square. You may give for 5 people n square. Here also worst case n square is there. Whenever sees one, whenever that day is not your day, random generator generating some numbers randomly, right? Those may leads to again worst case behavior. Randomly you are generating, sometimes those also may create trouble. Right? That is the reason I give you best example also. Prime Minister having lot of security. Still some people killed previous our prime ministers. What is the reason? That day is not their day. That may be the reason. 100% efficiency nowhere possible. Randomized quicksort is almost close to came to the 100% efficiency, but little bit, maybe you can say here 97%, right? 97% here random here, right? Here worst case may not happen. Here 99% worst case may not happen. But in the GATE exam, if someone asks you, right, randomized quicksort worst case, say n square. Right? Quicksort algorithm worst case, say n square. They will ask you, then what is the purpose of the randomization and all? They tried randomization because it is improving the performance. Here many cases are giving worst case, right? Here only few people are giving worst case, right? Something like that. Please be careful, right? If I don't say this point clearly, some people may mislead. Can you say a final conclusion? Quicksort best case n log n, average n log n, worst case n square. Randomized quicksort, right? Same. Then what is the difference? Randomization will improve the performance. Means quicksort is giving for 10 people worst case. Randomized quicksort may give for 5 people worst case. 100% efficiency nowhere may not be possible.